Hello students, welcome to the class. So as in previous class, we have discussed everything regarding redox reaction. What is redox reaction? What is oxidation reduction? What do we mean by oxidizing agents? What do we mean by reducing agents? What happens when there is a increase in the oxidation number? What happens when there is decrease in the oxidation number? Then different types of redox reactions. Then we have seen how to give a oxidation number to a particular element in that atom, or if it is a polyatomic ion, if it is a molecule. Then we have seen the balancing of the redox reactions. And lastly, we have seen regarding redox reactions as a part of titrimetric analysis, that is titrations. Okay. So with all these concepts in our mind, let us move to the multiple choice questions. And here I have the first question. Which of the following redox reaction? Which of the following is redox reaction? Evaporation of water, both oxidation and reduction, H2SO4 with NaOH, in atmosphere O3 from O2 by lightning. See, if you want to write the reactions for all, okay, so evaporation of water, H2O liquid, under the sunlight, heat or temperature of the sunlight, it gets converted to water vapor. This is evaporation. In both the cases, if you look at the oxidation states of both are water only, right? Both are water only. So neither anything is getting oxidized nor anything is getting reduced. Second option, if you see, oxidation and reduction. Yes, redox reaction means what? Redox reaction means wherein oxidation and reduction occur simultaneously. Simultaneously is called redox reaction. Take the third option. Third option is H2SO4 with NaOH. H2SO4 being acid reacts with NaOH to give Na2SO4 plus H2O. Yes. So this is what type of reaction? This is not redox reaction. Instead, it is neutralization reaction. It is neutralization reaction. Hydrogen +1, here also +1, here it will have +6, here also it is having +6. Nothing is getting oxidized nor reduced. Sodium, it is +1, here also it is +1. Oxygen -2, -2. See, nothing is going to reduce. Yeah. So I can see here, if I want to calculate for S here, sulfur, it is +1 into 2 plus X plus -2 into 4, correct? So here, what it will come to? 2 plus X minus 8. -8 plus 2 is -6. S becomes +6. Similarly, here I know this is +1, this is -2, this is +1, -2, +1. Sodium is +1, oxygen is -2, +1, -2. Sulfur again, if I want to calculate here, +1 into 2 plus X plus -2 into 4. See, same thing. Again, this will have +6. See, nothing is oxidizing, nothing is reduced there. So we have to look at all the options. And what is the last option? Last option is in atmosphere, formation of O3 from O2 by lightning. When oxygen combines with atmospheric, see what happens in atmosphere is oxygen molecule during lightning, it will break down into atomic oxygens. These atomic oxygens, they have one electron. Yes. So they are not charged particles. So this is also 0. Here also it is 0. This oxygen again, it will combine with atomic oxygen in lightning, during lightning, to form what? During lightning to form O3. Is there any reduction reaction taking place? Ozone, here also the oxidation state is -2. Here also it is -2. This is free radical, no charge. So where redox reaction means what? Oxidation and reduction occurring simultaneously. So option 1 is the correct option. Yes. So redox reactions are those chemical reactions which involve both oxidation and reduction occurring simultaneously. Moving to the next question. Okay. Without losing its concentration, ZnCl2 solution cannot be kept in contact with. Okay, without losing its concentration, ZnCl2 cannot be kept in contact with. See, they are given options: lead, aluminium, gold, silver. Okay, what type of expectations we have here with this question? See, if you look, they have said ZnCl2 concentration, and without losing its concentration, ZnCl2 can be kept in. That means with which of the elements ZnCl2 will not react. Yes. So if you look at remaining options, see in the reactivity series, when I speak about reactivity, I'll write here, when we speak about a reactivity series of metals, reactivity series of metals. So here I will mention it, reactivity series of metals. Yeah. So I'll just show you the reactivity series once so that you will remember it all the time. Potassium, most reactive, then comes sodium, then comes lithium, then comes barium, strontium, calcium, magnesium, aluminium, manganese, zinc, chromium, then iron we have, then cadmium, cobalt. So I will write it like this. Here I'll mention next part. After cobalt comes nickel, then we have tin, Sn stands for tin, then I have lead, I have hydrogen. This is the distinguishing character. Then antimony we have. Then we have bismuth, copper. Okay. Then I have mercury. Then we have silver, gold, platinum. Getting? So this is most reactive. And these are what? These, if you see, from gold onwards, from mercury onwards, they are least reactive. Least reactive. Okay, so here this is most reactive. So as you move down the series, the reactivity of the metals decreases. So these are least reactive. So reactivity of the metals decreases as you move down the group. So in the given options, which are our options given? The options given are, they have given lead, they have given aluminium, they have given gold, they have given silver, and here there is zinc. So let us observe those elements. So here we have zinc, fine. Okay, aluminium is here, then gold and all, gold, silver, and then lead, Pb, it is here. Are you all understanding? So what does that mean? If you look at aluminium, only aluminium lies above zinc in the reactivity series. Rest all, lead, gold, silver, they all are present below the zinc element in the reactivity series. So what I said in metal displacement, a most reactive element, or you can say more reactive element, displaces a less reactive element from its solution. Yes, from its solution. So only a more reactive element displaces a less reactive element from its solution. So from the given options, only aluminium is present above zinc. So zinc chloride is the solution. Only aluminium is present above zinc. Therefore, only aluminium can displace zinc from its solution to form aluminium chloride. So it will displace zinc from its solution. Therefore, concentration of zinc chloride will decrease when it is kept in aluminium. Otherwise, you keep zinc chloride in lead, nothing will happen. You keep zinc chloride in gold, nothing will happen. Zinc chloride in silver, nothing will happen. Only when zinc chloride is kept in lead, aluminium, it will form aluminium chloride. Therefore, concentration of zinc chloride will decrease when it is kept in aluminium chloride. So this is what? This is reactivity series. Yes. So correct option is what? By keeping zinc chloride in aluminium, the concentration of zinc chloride decreases. Is that understood? Okay. So it is based on reactivity series. What is the change in the oxidation number of carbon in the following reaction? So CH4 plus Cl2 gives CCl4 plus HCl. It is this last year NEET 2020 question. Okay, let us see. Fine. So it is the third question what we are going to discuss now. The reaction given is, I'll write the reaction, CH4 plus gaseous CH4, Cl2, they have already balanced the reaction and given, gives CCl4 plus 4HCl. Correct. Write the oxidation states. Let us see. Carbon here, hydrogen has got +1. Carbon +1 into 4 is +4. It becomes -4. So here 4Cl2, this is 0. Okay, here it is +1 and -1. Here Cl is -1. -1 into 4 is -4. It becomes +4. Getting? So how it is changing? It is changing from -4 to +4. The oxidation state is changing from -4 to +4. That means what is becoming? -4 is becoming -3, -3 is becoming -2, -2 is becoming -1. That means there is a loss of electrons. Yes, oxidation is taking place. Yes, this is losing electrons. Oxidation is taking place. Therefore, I can say in CH4, the oxidation number of carbon is -4, while in CCl4, the oxidation number of carbon is +4. Thus, change in oxidation state of carbon in the given reaction is from -4 to +4. It is from -4 to +4. Option C is the correct option. Last year question asked. Next question. The oxidation state of chromium in CrO5 is CrO5. Okay. Fourth one. Chromium in CrO5. See, CrO5. If you do with actual method, let us do it with actual method. This is -2. So x into 1 plus -2 into 5 is equal to 0. -10 becomes +10. So the chromium is having +10 oxidation state, which is impossible. Yes, chromium can have maximum of +6. Therefore, there must be something related with the structure. Write the structure of chromium. Chromium structure, if you see, we have discussed this in exceptional cases. Yes, it is bonded. There is peroxy linkage between the two oxygen atoms, and it is bonded with a double bond to one oxygen atom. Right? So now you calculate. This will have -1 peroxy linkage. Peroxide oxygen will have -1 charge. This is going to have -2. Calculate on chromium. So I will write x into 1 plus -2 into only one oxygen plus -1 into 4 oxygen atoms is equal to 0. So x -2 minus 4 is -6 equal to 0. So x, what is the oxidation state of chromium in CrO5? It is +6. It is what? +6. Is that clear? So we have to be very careful with the structure and what valency it can have, maximum valency. So it is what? It is +6. Done. Next, the correct structure of tribromo octaoxide. Tribromo octaoxide. Okay, I'll show it here only. Tribromo octaoxide. Tribromo octaoxide is, all should be in oxide, means there is no, they have not said ion, correct? So where there is no ionic charge present on the oxygen atoms, that becomes the structure. So this is the correct structure. Yes, there is no ions, the charge given here. Yes, you can calculate with the formal charge also. Where there is most stable formal charge, that becomes the correct option. So this is nothing but tribromo octaoxide. Tribromo octaoxide. So 3 Br atoms, each Br is linked to double bonded oxygens, 3 oxygens through all double bonds. Yes. So middle Br, there are 2 oxygen atoms linked through a double bond, and here also there is 3 oxygen atoms linked through a double bond. Yes, so that is the correct structure. They have not said ion, so this becomes the correct structure. Next question. Which of the following reactions are disproportionation reactions? Okay, we will take all the reactions, do it and see. Fine. Okay, so I will take it here itself. So it is sixth question, if I'm not wrong. Fine. Let us take first option. 2Cu plus gives Cu plus 2 plus Cu0. Okay. Next option, what is given is 3MnO4 minus 2 plus 4H plus gives okay, sorry, 2MnO4 minus plus MnO2 plus 2H2O. This is second option. Third option, 2KMnO4 gives on heating K2MnO4 plus MnO2 plus O2. And last option is 2MnO4 minus plus 3Mn plus 2 gives, sorry, plus H2O. Here we have still plus 2H2O gives, it's 5MnO2 plus 4H plus 4H plus. So they have asked which is disproportionation reaction. Now disproportionation reaction means what? Disproportionation reactions are those where the same element or a compound gets oxidized and reduced simultaneously. Okay, first we will write the oxidation states. Cu here is plus 1, here it has become plus 2, it has become 0. So Cu from plus 1 has become plus 2, oxidized, and from plus 1 it has become 0, reduced. So increase in oxidation number, oxidation, decrease in oxidation number, reduction. Yes, so this is disproportionation reaction. Okay, fine. Take the second option, MnO4 minus 2. Find the oxidation state first, X here. So minus 2 4s are 8, minus 8, that side becomes plus 8. MnO4 minus 2. So minus 2 minus 8, 4 2s are 8. So it becomes plus 6. Okay, then 4H plus. So it is plus 1 charge. 2 MnO4 minus. So minus 1 into 4 is how much? Minus 4. This becomes plus 4. This is minus 2. And here MnO2, if you see, oxygen is minus 2, minus 2, minus 2 is, so it is again plus 4 here. Okay. So what is happening here? Here if you see, Mn from plus 6, it is becoming plus 4. MnO4 minus, see they have balanced it, right? So when you write along with balanced equation, it becomes a 7 here. Minus 2. Okay, the whole charge is given. I'm extremely sorry. Let us take it like this. Whole charge is be given. So how much they have given? MnO4 minus 2. MnO4 minus 2. And this is MnO minus. Okay. So if I calculate the charge, the MnO4 minus 2. Okay. So let us calculate here X plus minus 2 into 4 is equal to minus 2. Correct? So minus 4, minus 2 into 4 is minus 8. Minus 8 becomes plus 6. So here Mn is plus 6. Here Mn is how much? X plus minus 2 into 4 is minus 8. Minus 2 into 4 is equal to minus 1. Minus 8 and this side goes this side. So it becomes plus 8. It is plus 7 here. Okay, fine. Okay, we understood the oxidation states of Mn. So let us verify now. So Mn from plus 6, it is becoming plus 7. And Mn from plus 6, it is becoming plus 4. So there is increase in the oxidation number, oxidation. Plus 6 is becoming plus 4. That means by gaining electrons, it is becoming plus 4, reduction. So both oxidation and reduction are taking place with the same element. Similarly, go for KMnO4. KMnO4. Potassium plus 1. So plus 1, this is x minus 2. Minus 2 minus 8, it becomes minus 8 plus 1 is minus 7. So Mn is having plus 7 charge here. Correct? So it is plus 7. K2 MnO4. So this is 2. This is minus 8. This is becoming plus 6. And MnO2 here plus 4. Is that right? MnO2 plus 4 it is becoming. So plus 1 into 2 plus x plus minus 2 into 4. So minus 2 into 4 is how much? Minus 8. Minus 8, this becomes plus 6. Here KMnO4 plus 7 it is plus 1. Here minus 2, 4 to the 8 plus 7 it becomes. So this is correct. Okay, fine. So what is happening? I can write here Mn from plus 7 it is becoming Mn plus 6. Mn from plus 7 it is becoming Mn plus 4. That means both the cases it is gain of electrons. Therefore it is only reduction. It is only reduction. Correct? Take the last option. Take the last option. MnO4 minus. Just now we have seen MnO4 minus. Mn is plus 7. Here Mn plus is there. And here MnO4. MnO2. So MnO2 means x minus 2. This is plus 4. Right? Okay. So Mn here it is plus 7. It is becoming plus 4. And here Mn is plus. It is becoming plus 4. So in both the cases what? There is gain of electrons again. Gain of electrons means what? So plus 7 is becoming plus 4 is becoming plus 7, plus 4 is becoming plus 1. Okay, plus 1 is becoming plus 4. So this is what? 7 to 4, it is loss, gain of electrons. 1 to 4, it is loss of electrons. But here it is two different atoms. Two different on the reactant side. Yes, it cannot be possible. Therefore, which is the correct option? It is first one and second one. First one and second one show the correct disproportionation reaction. Rest all do not show the disproportionation reaction. So the correct option, let us see. Okay, they have given select. So it is option B. Option B is the correct option. Is that clear? So this is how we will do the disproportionation reaction. Next one, the correct order of nitrogen compounds in the decreasing order of its oxidation states. So HNO3 is given, NO is given, N2, NH4Cl. Okay. So same compounds are there. We will find it out. Seventh question. So what are the compounds? HNO3. Then they have given NO. Then they have given N2. Then we have NH4Cl. Find the oxidation states of all of them and then arrange them in the decreasing order. So here it is plus 1 into 1 plus x plus minus 2 into 3 is equal to 0. All are molecules, so equal to 0. Plus 1 minus 6. So it becomes 5. So nitrogen here it is plus 5. Okay. NO x plus minus 2. So it is plus 2. NO, nitrogen plus 2. Here nitrogen is 0, elemental state. NH4Cl, x plus 1 into 4 plus minus 1. So 4 minus 1 is 3. So it is minus 3 in this case. It is minus 3. So arrange them in the decreasing order. So highest is what? Highest is HNO3. So HNO3 is highest. Oxidation state is plus 5. Then comes the second highest is NO, whose oxidation state is plus 2. Then comes N2, whose oxidation state is 0. Then comes NH4Cl, whose oxidation state is minus 3. Yes. So this is the correct order, decreasing order of the oxidation states of nitrogen in the given compounds. So which is the correct option? Correct option is option A. It is option A. Okay. Next, for the redox reaction, MnO4 minus plus C2O4 2 minus plus H plus gives Mn plus 2 plus CO2 plus H2O. The correct coefficients of the reactants for the balanced equations are. Yes. So how do we do it? Either go by which one? Either go by oxidation number method or go by half reaction method, you should balance this reaction, redox reaction. So when you go by the method, when you try to balance it out, yes, let us see it. Okay. By oxidation number method, write the reaction MnO4 minus plus C2O4 minus 2 plus H plus gives Mn plus 2 plus CO2 plus H2O. Okay, identify. First step is what? Identify, write the oxidation states. MnO4 minus. So minus 2, minus 8. Minus 8 equal to minus 1. So it is plus 7. Correct. Plus 7. Here, carbon. So it is x, 2x minus 8. 8 by 2, 4 plus 4. Then here Mn plus 2. Here carbon minus 2. Minus 2 2s are 4. So 4 means what? Minus 4. Okay. So minus 4. So what is oxidation and what is reduction? Which is getting oxidized and which is getting reduced? Identify that. So Mn plus 7 is becoming Mn plus 2. That means gain of electrons. That is reduction. And C2O4, carbon from plus 4, it is becoming minus 4. That means it is gaining electrons. Plus 4, plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3, minus 4. So it is gaining electrons. Yes. So what we will do further in the next step? So we will identify the oxidation half and the reduction half. So we will balance it by half cell reaction method. So here I will write oxidation half and here we will take reduction half. Yes, do it fast. So Mn oxidation half is what? MnO4 is becoming Mn plus 2. MnO4 is becoming, MnO4 minus is becoming Mn plus 2. And here C2O4 minus 2 is becoming what? CO2. Yes or no? Okay, fine. Second step, what you will do? You will balance all the atoms except oxygen and hydrogen. So MnO4, Mn plus 2, it is balanced. C2, so I will, what I'll do? C2O4 minus 2, I will write 2 CO2. So atoms have been balanced. Now to balance oxygen, write H2O molecules on the other side. Right? Okay. So C2O4 minus 2. Here there are 4 oxygen atoms. Here also there are 4 oxygen atoms. So I need not balance. Here MnO4 minus gives Mn plus 2 plus how many oxygens? 4. Therefore I write 4 H2O. To balance hydrogens, I will write how many H plus here? I will write 8 H plus. 8 H plus. Correct? Yes. Okay. Further, so if you see here, we have written half cells reactions. We have to separate them properly now. This reaction, since it is H plus, it is in acidic medium. It is in what? Acidic medium. Now balance the charges. Go on balancing the charges. So how do we balance the charges? So here I have written how many charges are there here? Calculate minus 1 plus. So here there are 8 minus 1, 7 charges. And here there are plus 2. So MnO4 is becoming MnO4 minus, that means plus 7 is becoming plus 2. And here it is becoming carbon plus 4 is becoming minus 4. So when we balance the charges, we will get it as final equation I'm writing 2 MnO4 minus, after balancing the charges and then equating the number, multiplying the equation relative charges, we will get the final equation as 2 MnO4 minus plus 16H plus 5 C2O4 minus 2 gives 2 Mn plus 2 plus 8 H2O plus 10 CO2. 8 H2O plus 10 CO2. Because when we try to balance here, you can see here there are how many electrons? 7 to 4. 7 to 4 means 5 electrons, and here minus 4 to plus 4. Plus 4 to minus 4 means how much? Plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3, minus 4, 8 electrons. So when that has to be balanced, means we will multiply it by, the electrons have to be multiplied, right? So multiplied by 6 electrons this side, 5 electrons. So 2 into 5 we will do. When we do that, we will get this particular equation. Yes. So this is our final equation. So it is MnO4 minus 2, that plus 16H plus 5C2O4 minus 2 gives 2Mn plus 2 plus 8H2O plus 10CO2. So which is our correct option? What are the coefficients for MnO4 minus? The coefficient for MnO4 minus is 2. I'll write it here also if you want. 2MnO4 minus plus CrO4 will get 5C2O4 minus 2 plus 16H plus gives 2Mn plus 2 plus 10CO2 plus 8H2O. This is what we get, correct? So coefficient for MnO4 minus is how much? 2. So 2, both options are there. C2O4 minus is 5. So this is the correct option. C2O4 minus is 5. And then H plus, how many? 16H plus. So option B is the correct option. Either go by oxidation number method or go by half reaction method, you will get the same option. Okay. Next, hot concentrated sulfuric acid is moderately strong oxidizing agent. Which of the following reactions does not show oxidizing behavior? So which reaction? Everywhere we have used concentrated sulfuric acid, which is strong oxidizing agent, which will not show oxidizing behavior. Yes. So where oxidation number remains same, that will not show oxidizing behavior. So we will, yes, rather than going there, we'll try to write it here only. Okay. Okay. Cu is 0 here. It is becoming plus 2. Then sulfur is 0. Here minus 2, minus 2, 2 is 4. Here it is becoming plus 4. Then carbon is 0, elemental state. Here it is plus 4. Then calcium plus 2. Here also it is plus 2. So if you observe in first option, the oxidation state is changing from 0 to plus 2. So loss of electrons, oxidation is occurring. Sulfur 0 to plus 4. Again, loss of 4 electrons, oxidation is taking place. Therefore, H2SO4 is a strong oxidizing agent. Carbon 0 to plus 4. Again, 4 electrons are lost. It is oxidizing agent. Whereas calcium from plus 2, it is remaining plus 2 only. So in this reaction, the oxidation state of every atom remains the same. Even fluorine, you see, fluorine is minus 1 here. Here also it is minus 1. So you have to see this itself, right? So the oxidation state is remaining same. Therefore, this is not showing, in this case, H2SO4 is not showing oxidizing behavior. It is not showing oxidizing behavior. Is that right? Understood. So we have to check where the oxidation states are remaining same. Next question. H2O2, hydrogen peroxide plus ozone gives H2O plus 2O2. H2O2 plus silver oxide gives Ag plus H2O plus O2. Role of hydrogen peroxide in above reactions is respectively. Okay. Do the reaction. Write the reaction and see. The reaction is first case H2O2 plus O3 gives H2O plus 2O2. Okay, what is happening in this first reaction? You can see here hydrogen is plus 1. Hydrogen peroxide, in peroxide both the oxygens have minus 2, sorry, both the oxygens have minus 1 charge, correct? Because hydrogen peroxide, in peroxide only, the oxygen will have what charge? It will have minus 1 charge. It will have minus 1 charge. Ozone is 0. Okay. Further, what is happening? Here it is plus 1, here it is minus 2, and here it is 0. Is that right? So let us see what is happening here. Oxygen from minus 1, it is becoming what? It is becoming can I say it is becoming 0? So from minus 1 to 0 it is becoming. Further, ozone from 0 it is becoming what? From 0 ozone is becoming minus 2, correct? Getting my point? Understanding? So what do we understand from this? See, from -1 to 0 means what? There is increase in oxidation number. So when there is increase in oxidation number, what is such a substance called? We call it as reducing agent. We have seen. So reducing agent helps in oxidation and therefore gets, reducing agent helps in reduction and therefore gets oxidized, increase in oxidation number. From 0 to -2, what is happening? There is a decrease in oxidation number. Oxidation number. That means what it is? It is oxidizing agent. Okay, fine. Look at the second option. What is the second option? H2O2 plus Ag2O gives what? Gives 2Ag plus H2O plus O2. Fine. Write the oxidation states. Here +1, -1. Here it is -2. Silver is +1. So -2 into 1. So 2x. So 2 by 2 is +1. Here it is becoming 0. +1, -2. And here it is elemental state 0. Okay. Form the oxidation states. So what is happening? From -1 to oxygen, it is becoming 0 here. What is happening there? What is happening there? From -1 to 0 means what? From -1 to 0 means there is increase in the oxidation number. Oxidation number. So what type of reagent? Reducing agent. Yes. And if you look silver oxide, from +1 it is becoming 0. So there is decrease in oxidation number. Therefore, I can say H2O2 acts as reducing agent in both the reactions in which oxygen gas is evolved. H2O2 acts as reducing agent in both the reactions. Yes or no? Here also it is reducing agent. Here also it is reducing agent. What it is reducing? In this case, it is reducing ozone to H2O. And in this case, it is reducing silver oxide to silver. So in both the cases, it acts as reducing agent. So which forms the correct option? Reducing agent in 1 and 2. So in both the cases, it acts as reducing agent. Next question. The pair of compounds that can exist is FeCl3 SnCl2, HgCl2 SnCl2, FeCl2 SnCl2, and FeCl3Ki. See, if you look at all the 4 options, out of 4 options, option C, FeCl2 and SnCl2, that is ferrous chloride and stannous chloride, both are reducing agents. Yes, with low oxidation states. And therefore, they are the pair of compounds that can exist together. Yes, that can exist together. Next question. A mixture of potassium chlorate, KClO3, oxalic acid, C2H2O4, and sulfuric acid, H2SO4. During the reaction, which element undergoes maximum change in the oxidation state? For such questions, write the reaction itself. So what is the reaction? They have said potassium chlorate, KClO3 plus oxalic acid. I will write it as COOH twice, or you can write it as C2H2O4 plus sulfuric acid, H2SO4, gives what? It gives K2SO4, potassium sulfate, plus KCl, potassium chloride, plus CO2 plus H2O. Okay, it gives this compounds. Now, write the oxidation states. I want for chlorine +1 -2. So +1 plus X -6 plus 5 -5. So it becomes +5. So here chlorine is +5. Carbon, oxygen is -2 +1. So 2X plus 2 -8. So -6, it is +3. Okay. H2SO4 +1 -2. So 2 -8 becomes a 6. So +6. Correct. Here, what is happening? +1 -2. So 2 -8 is 6 plus 6 it is. Here plus 1 minus 1, carbon dioxide minus 2 plus 4, water plus 1 minus 2. So this is all the oxidation states. Okay, now observe where there is maximum change in the oxidation number. Potassium from plus 1 it is remaining plus 1 only. So there is no change. Chlorine from plus 5 it is becoming what? It is becoming minus 1. Okay. Then oxygen from minus 2 it is remaining minus 2 only. Carbon plus 3 it is becoming plus 4. Hardly one change. Then any other change? Hydrogen is remaining same, plus 1 to plus 1 only. Then sulfur from plus 6 it is remaining plus 6 only. So there is change only in chlorine and carbon. Carbon change is not that much. See, chlorine from plus 5 it is becoming minus 1. That means plus 5 plus 4 plus 3. See, plus 5 plus 4 plus 3 plus 2 plus 1 0 then minus 1. So from plus 5 to plus 1. So maximum change in the oxidation number occurs in case of chlorine. It occurs in case of chlorine. Is that right? So it occurs in case of chlorine. Yes, so Cl is the correct option. Next question. Oxidation number of phosphorus in PO4 minus 3, sulfur in SO4 minus 2, and chromium in Cr2O7. Here only we will do it and check. Phosphorus in PO4 minus 3 they have said. So, and then next option is sulfur in SO4 minus 2, and last option is chromium in Cr2O7 minus 2. Okay. X plus minus 2 into 4 equal to minus 3. So minus 8. 8 minus 3 is what? 8 minus 3 is plus 5. So phosphorus oxidation state is plus 5. Okay, sulfur. X plus minus 2 into 4 is equal to minus 2. So 4 to the 8. 8 minus 2 is 6. So sulfur is plus 6. Chromium, it is 2x because x into 2 plus minus 2 into 7 is equal to minus 2. 14. 14 minus 2 is 12. X is 12 by 2. It is plus 6. So what is the oxidation states? Oxidation state of phosphorus in PO4 is plus 5. Oxidation state of sulfur in SO4 minus 2 is plus 6. And oxidation state of chromium in Cr2O7 minus 2 is plus 6. So which is the correct option? The correct option is option plus 5 phosphorus plus 6 sulfur plus 6 chromium. So option D is the correct option. Yes, option D is the correct option. Next question. Number of moles of MnO4 minus required to oxidize 1 mole of ferrous oxalate completely in acidic medium will be. Okay, we will see this reaction here. So what they have said, they have taken number of moles of MnO4 minus. So MnO4 minus required to oxidize 1 mole of ferrous oxalate. Yes, 1 mole of ferrous oxalate completely in acidic medium. Ferrous oxalate means we have which ion? We have C2O4 minus 2. Okay, so I have two ions here, C2O4 minus 2. So these are the two ions. So MnO4 minus is will become what? It will become Mn plus 2. Mn plus 2. And C2O4 minus will become what? It will become CO2. CO2. So balance the reaction first. So here if I want to balance, Mn is balanced, carbon, I will write 2 CO2. So observe, you will not sit doing stepwise. Directly you can go. Oxygen you want to balance. So here you will write what? You will write required number of hydrogens as 4H2O, oxygens as 4H2O. To balance hydrogens, here you will write 8H plus ions. Now how many charges? Balance the charges. Here minus 1, 7 charges are there. This side you have 2 charges plus 2. So here it is 7. So to balance 2 means what? I have to multiply this by 2. Okay. Here C2O4 minus 2CO2. So here minus 2 is there. So if I gain those 2 electrons, it will become neutral. It will become 2. So minus 2 minus 2. I shouldn't write it here. So I have to balance it on the other side, right? So here I will write 2 electrons. So it is balanced. C2O4 minus 2. Here I will write 2 electrons. Correct? And this equation I will multiply it by 5. Is that right? Solve it out. Write the entire reaction multiplied by 2. Entire reaction multiplied by 5. So I will write here 2MnO4 minus plus 8 to the 16H plus 5 C2O4 minus gives 2Mn plus 8 H2O plus 10 CO2. Electrons gets cancelled. Electron gets cancelled. Here we have 5 electrons. 5 electrons. I have to balance it. Okay. So you can see here 2 5s are 10 electrons, 2 5s are 10 electrons. Electrons gets cancelled. Electrons get cancelled. Now if you see 2 moles from the equation, 2 moles of MnO4 minus are required to oxidize. How many moles of oxalate? How many moles of oxalate? 5 moles of oxalate. 5 moles of oxalate. Question asked is number of moles of MnO4 minus required to oxidize 1 mole. So how many moles of MnO4 minus are required to oxidize 1 mole of oxalate? So how do we do it? It is nothing but for 1 mole of oxalate, it is 5 by 2. Is that right? No, it is 2 by 5. It is 2 by 5. So 2 divided by 5 comes out to. So 2 by 5 is how much? 2 by 5 is 0.4. 5 ones are 0.5 fours are 20. So how much we get? Option, we get 0.4. 0.4 moles. So option D is the correct option. Is that understood? Okay. Which is the best description of the behavior of bromine in the reaction given below? H2O plus Br2 gives HOBr plus HBr. Okay. So the reaction is H2O plus Br2 gives HOBr plus HBr. Okay. I'm sorry. So here it is plus 1 minus 2. They have asked for bromine, so need not write for 0. Elemental bromine is 0. Here plus 1 minus 2 means this will have how much? So plus 1 minus 2 is minus 1. It becomes plus 1. So Br is having plus 1 charge here. Here plus 1 minus 1. So Br from 0 it is becoming, in HOBr it is becoming plus 1. So 0 to plus 1. And from Br to 0, it is becoming HBr. In HBr, it is becoming minus 1. That means from 0, it is becoming minus 1. So here it is losing 1 electron. Here it is gaining 1 electron. So if you look at the above equation, oxidation number of bromine increases from 0 to plus 1. And oxidation number of bromine decreases from 0 to minus 1. Thus, Br2 is what? Here it is oxidized and here it is reduced. So it is both oxidized as well as reduced. Understood? It is both oxidized as well as reduced. So what type of reaction it is? It is an example for disproportionation reaction. Example for disproportionation reaction. Next, the oxidation states of sulfur in the anions SO3 minus 2, S2O4 minus 2, S2O6 minus 2 follow the order. Do it. I'm sorry. Do it and tell me. So we can do it here. So what are the compounds given? They have said SO3, all are ions. SO3 minus 2. Then second ion is S2O4 minus 2. Then third ion is S2O6 minus 2. Okay. So solve it out. X, one atom. So I will not worry. Minus 2 into 3 is equal to minus 2. So minus 2, 3 to the 6. 6 minus 2 is 4. So sulfur here it is plus 4. Correct. Next, X into 2, 2 atoms are there, plus minus 2 into 4 is equal to minus 2. So minus 8, 8 minus 2 is 6, 6 by 2 is 3. Sulfur is plus 3. S2O4, it is plus 3. Next, X into 2 plus minus 2 into 6 is equal to minus 2. 6 2s are 12, 12 minus 2 is 10, 10 by 2 is 5. It is plus 5. It is plus 5. So which is having oxidation states? They follow the order. What order they follow? So I can write here S2O4 minus 2. It is having what? It is having plus 3 charge. Then it is less than SO3 minus 2, which is having plus 4 charge, which is less than S2O6 minus 2. So what is the charge here? Plus 3 on sulfur. Here it is plus 4 and here it is plus 6. So which is the correct order? Look at the options. Which satisfies our answer is the correct order. It is option S2O4 minus 2 less. Yes, it is option A itself. It is option A. Is that clear? Next question. Oxidation state of iron in Fe3O4. Fe3O4. X into 3 plus minus 2 into 4 is equal to 0. Minus 8 becomes plus 8. So X will be equal to what? 8 by 3. It will be equal to plus 8 by 3. So option D is the correct option. It is plus 8 by 3. Direct. Fe3O4. It is a ore of iron, magnetite ore it is. Fe2O3 is hematite. Fe3O4 is magnetite ore. Reaction of sodium thiosulfate with iodine gives sodium thiosulfate. I'll write the reaction here itself. Sodium thiosulfate is Na2S2O3 plus iodine I2 gives what? It gives Na2S4O6 plus NaI. NaI. Balance the reaction. Na here I will write 2 because iodine is 2. So 2 2s are 4. So I will balance it by writing 2 here. S4, 3 2s are 6. So it is balanced. This compound is called sodium. We have discussed the structure of it, right? Sodium tetrathionate. We have seen exceptional behavior when you are doing the the oxidation number. Exceptional behavior we have seen sodium tetrathionate. So when sodium thiosulfate reacts with iodine, we get sodium tetrathionate. So tetrathionate ion is obtained. The oxidation state of iodine. The oxidation state of iodine in H4IO6 is H4IO6 minus. Okay. Plus 1 into 4 plus X plus minus 2 into 6 is equal to minus 1. So 4 plus X minus 8 is equal to minus 1. Okay. So it is minus 4 goes here plus 4. 4 minus 1 is 3. So we will expect the answer to be 3. Yes. So since the oxidation state of hydrogen is plus 1, oxygen is minus 2. So 6 2s, I'm sorry, 6 2s are 12, minus 12. So minus 12 plus 4 is how much? Minus 8. Minus 8 becomes here plus 8. So it is 7. What is the oxidation state? It is plus 7. Of iodine, it is plus 7. 6 2s are 12 it is. I had written 8. So minus 12 plus 4 is minus 8. Plus 8 it becomes plus 8 minus 1 is 7. So it is plus 7 is the oxidation state of iodine. Next question. Which substance is serving as reducing agent in the following reaction? Find it here itself. H plus C2O4 minus 2. So minus 2, 7 2s are 14. 14 minus 2. So here it is minus 14 plus 14. 14 minus 2 is 12. 12 by 2 is 6. So oxidation state of chromium is 6. Here it is 0. Here we need not worry. Chromium is plus 3. So chromium from plus 6, it is becoming chromium plus 3. Nickel from 0, it is becoming Ni plus 2. So they have asked which is reducing agent. See here what is happening. Here there is gain of electrons. So gain of electrons is what? Reduction. And here there is loss of electrons. This is oxidation. So which is reducing agent? Reducing agent is the one which helps in reduction and itself gets oxidized. So where it is getting oxidized, Ni, the oxidation number of Ni increases from 0 to 1. So therefore Ni acts as reducing agent. So what is the speciality of reducing agent? It's oxidation state. There will be increase in oxidation state. For oxidizing agent, there will be decrease in oxidation state, opposite of oxidation and reduction. Yes, so here there is increase in the oxidation number. Therefore, Ni acts as the reducing agent. It acts as the reducing agent. Is that right? Okay. So this question we have discussed just now. Fine. Next question. Consider the change in oxidation state of bromine corresponding to different EMF values, electromotive force values, as shown in the given diagram. Okay, they have given this. Then the species undergoing disproportionation. Okay, we will work out this. We'll work out here. What they have said, they have given the reaction BrO4 minus 1.82 volts, BrO3 minus, I will write it here, BrO4 minus is forming with 1.82 electro EMF value, BrO3 minus, then with 1.5 volts it is forming HBrO, then with 1.595 volts it is forming Br2, and then with 1.0652 volts it is forming Br minus. So they have given the EMF values. For a reaction to be spontaneous, the E0 cell of a reaction should be positive. Yes, as the reaction says equation says delta G0 is equal to minus NF E0 cell. So if this is positive, then whole thing becomes negative, delta G0 will be negative. So let us see it for various examples. If you see here, I'll consider HBrO giving what? It is giving Br2. Correct. What they have given the value? They have given value as E0 is equal to 1.595 volts. Yes. So this is standard reduction potential which occurs at cathode. Okay. Then if you see HBrO forming BrO3 minus, I've taken opposite, reverse. So if this is in plus, I will write it in minus. E0 is minus 1.5 volt. This is what? Oxidation potential which occurs at anode. Okay. Then if I compare them, HBrO, two molecules, then I'm getting Br2 plus BrO3 minus, correct? See here. If I go this way, it is plus. If I go this way, it becomes minus. So if I take two molecules, one is forming Br2, another one is forming BrO3 minus. Similarly, you can compare for all different. But here, this is the consideration case. So E0 of a cell, we calculate it as is equal to, standard reduction potential which occurs at cathode minus oxidation potential with reduction potential which occurs at cathode, reduction potential which occurs at anode. That is nothing but 1.595 minus 1.5. Answer comes out to 0.095 volts. 0.095 volts. So 0.095 means what? E0 of a cell is greater than 0. That means delta G. That means E0 is positive. So in this case, delta G0 will be negative and the process will be spontaneous. Very differently asked question. So which is the correct option? Here, the correct option is in case of HBRO, the species will undergo disproportionation. One is becoming 0. Here, BR value is what? Yes, you can see here. BR, it is 0, +1 -2. So it is -3. Here, +3 it is. It is becoming 0. And here, -2. 3 to the 6. It is becoming +6. So from +3, it is becoming +6. From +3, it is becoming 0. So only here it undergoes disproportionation. Or you can, if they are, since they have given different EMF values, from based on EMF value, we can calculate and say it like that. So we have discussed around 22 questions. Yes, in the next class, we'll discuss the next set of questions. I hope you have followed with all the questions. Do practice them. In the next class, we will take the next set. Thank you.